I'm going to do two examples of Bayes' theorem. First of all, we're given this tree diagram with various probabilities written in, and we're asked for these three computations. The probability that you get A on the first stage is just the 40% there. The probability that you get D given A, well, you can start at A and say, what is my probability to go on the D branch? That's 0.2. Where Bayes' theorem comes into play is the probability that you have A given D. And we can't do that based on the tree diagram. We don't have the conditional probabilities in that order. So I'm going to use Bayes' theorem to rewrite this. Okay. The first stage becomes my partition. So this is going to turn into the probability of A times the probability of D given A, switches the order to the one I know, divided by probability of A, probability of D given A. This is always a repeat of the top, plus, then I take this and switch out the A for every other option in the partition, which is just, in this case, B. So the probability of B times probability of D given B. Okay. So, I end up with 0.4 times 0.2 over 0.4 times 0.2 plus probability of B is 0.6. Probability of D given B is that 0.25. So this works out to 0.347826. Okay. Another one. Statistically, we know that 89% of the people arrested for serious crimes, 89% are male and 11% are female. Of the males, 30% are under 18. Of the females, 20% are under 18. That means those are conditional probabilities. So I know the probability they're under 18 given they're male, or they're under 18 given they're female. Okay. I want to compute these two. So first, the probability that they're under 18, period, needs to take into account both the males and the females, because these I only know once I know the sex. So this is going to be the probability that they're male and under 18, plus the probability they're female and under 18. Okay, so the probability they're male is 89%, and then 30% of those are under 18. The probability that they're female is 11%, and then 27% of those are under 18. And in total, I get 29.67% of the people arrested for serious crimes are under 18. Now for this one, this is where Bayes' theorem comes in. I want the probability they're female given that they're under 18. Whereas I know the probability that they're under 18 given that they're female. Okay. So using Bayes' theorem, this becomes probability that they're female times probability of under 18 given female. Okay. I repeat that down here. And then add to it what I get when I change the partition. And the first part, the partition was the first stage, the male-female. So it's now probability of male times probability that they're under 18 given they're male. Okay. So I get 0.11. Probability they're under 18 given female is 0.27. Okay, I'm going to repeat that piece. And then plus probability they're male times the probability, if they're male, that they're under 18. And I get a probability of just over 11% of the people under 18 happen to be female.